Okay, so you just wrote these down. We just said that the way we're going to simplify is we're going to change everything to sine and cosine and then do algebra. And some of the algebra that we probably forgot are some fraction rules. Like when you multiply fractions, you multiply left to right, and you can cancel up and down, diagonals, but not side to side. If you need to pause to write this down, you can. When you divide, remember you do a little Tyler Townley, you keep, change, flip, or you can cancel the denominators if they're alike. We'll show it. I'll go over examples of all these in a second. When you add and subtract fraction rules, you have to have the same denominator. If not, you do a LCD. And then something that your homework is going to use is the phrase divide out the common factor. Dividing out the common factor just means when you cancel, when you're multiplying. That's all it means. And then another thing that the homework says is separating the quotient into two terms. And we'll go over what that means, like for real, an example. But right now, I'll just tell you it's when you split a fraction into two. Okay, so pause and write this down. All right, so we are going to go over basically an example from all of your homework problems because this is strange and you are going to feel strange. Okay, so let's go. Let's do an example like number 1 on your homework. It says simplify tangent theta cosine theta. And remember, our very first step is to try and plug in sines and cosines. So we're going to take something that has a tangent and a cosine, that's two trig functions, and we're going to try and wheedle it down. We're going to try and make it smaller so that it's just 1. So we're trying to make these two suckers become 1 by simplifying and using those identities. And remember, we're changing everything to sines and cosines. So if I pull up these identities again and look for tangent, tangent right here, the reciprocal is 1 over cotangent, but that's useless because I want to change everything to sines and cosines, so I can't use that tangent. This tangent says some hooey about negatives and blah, 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 but that's useless because it's not equal to sine and cosine. Here's a tangent in the Pythagoreans, but that's useless because the rest of the equation does not say sines and cosines. And white bread is probably saying, why don't you just do the quotient? So let's look at tangent. Tangent as a quotient or a ratio is equal to sines and cosines. Sine over cosine. That's what we want to do first off. So that's what we're going to do. We are going to use the quotient identity to work on this tangent. And we just said that tangent is equal to sine theta over cosine theta. And remember I said sines and cosines are what you want. So since this cosine theta that they gave us is already cosine, I'm not going to mess with it. I'm just going to bring it down. Okay, what the heck are these two things doing to each other? Is there a plus sign, like this problem? Is there a minus sign? Is there a divide? There's a multiply sign. Okay. Now, how can I make this smaller into just one thing? Well, let's remember our fraction rules. You can cancel up and down diagonally, not side to side. And that canceling is called dividing out the common factor. So that's what we can do. Cross out these cosines. And you get sine theta. What? That's like a thing. If you don't believe me that those cross out, let's just pretend I put a 1 underneath. 1. And then I multiply left to right. Sine times cosine is sine theta, cosine theta. On the bottom, cosine times 1 is cosine theta. And then shoot fire, look, those cosines cancel, and you just get sine theta. So anyway, we simplified it, and my answer is just sine theta. Yeah. So on your homework, in the little box that you type in your answer, you're just going to type sine. Okay, don't get cocky. They're not always this easy. Okay, we're actually going to skip the one like number 2 on your homework because it's kind of cranky. So we'll come back to this. Let's do this example. Again, if you need to pause, do it. We want to simplify this. So first we change everything to sines and cosines. They're already sines. Hallelujah. No replacing, nothing. Okay, good. The second step is if we have fractions, we got to use our fraction rules. When we add or subtract, you must have the same denominator. I don't. One's a plus, one's a minus. So what we have to do is make a LCD. So my LCD is basically both the denominators squashed together. Sine theta plus 1, sine theta minus 1. Yeah. Okay, and then you multiply basically by the opposite denominator or by what you're missing. So over here on this left fraction, I'm missing sine theta minus 1. So I'm going to multiply that on top and bottom. Quit having a panic attack, okay? Now let's look at this right-hand fraction. I'm basically going to multiply by the other denominator, or if you look at your LCD, I have the sine theta minus 1 right here, but I'm missing the plus 1. So I'm going to multiply by sine theta plus 1. Okay, so let's do it. If I do that, this first fraction, 1 times sine theta minus 1. Well, sure enough, that's sine theta minus 1. All over, I'll just rewrite it for now, and then in a second, I'm probably going to multiply it out. Sine theta plus 1, and this red sine theta minus 1. Okay, subtract. Let's work on this second fraction. 1 times sine theta plus 1 is just sine theta plus 1. And on the bottom, I'm just going to rewrite it because I don't got time for that right now. Okay, so now that my denominators are the same, check it. They're the same. They're kind of swapped around the parentheses, but it's the same thing. So now that they're the same, I can combine these two fractions. And when I combine fractions, like when I add or subtract, I just rewrite the denominator. If you need to pause, do so. Okay, now let's write down what's on the top. On this left fraction, I have sine theta minus 1, subtract, and then, whoa doggy, I have sine theta plus 1. And the reason I wrote it in red is because I'm subtracting both of them, as in parentheses. Okay, so I'm subtracting more than one thing on this second fraction, so I had to use parentheses. Okay, let's distributize, and things are going to start canceling. Quit panicking. Okay, so on my fraction, the denominator stays the same because I'm not going to do anything. I'm just working on the top. The top left stays the same. I'm not doing anything. Over here on this top right, it distributes. And now we have minus sine theta, negative times 1, minus 1. Okay, let's see if anything can cancel. Just normal math. Sine theta, negative sine theta. They cancel. Okay, now let's combine the negative 1 minus 1. That does not make 0, you fools. That makes negative 2. Over that LCD. Okay, let's remember the whole point of this. The whole point of this was to make it smaller. So far, we've taken these original 2 fractions and we've made it into 1 fraction. Hallelujah. But I can still probably do something else. You might not think so, but just trust me. Okay, we're gonna FOIL this bottom stuff. Or, if you notice, it's basically the same thing, multiply the same thing, except for one's a plus and one's a minus. That's a difference of squares. What the poop? So I don't even have to FOIL. I can just flip. Yeah, so let's flip. We do sine times sine is sine squared theta. And it's weird, you put this tiny 2 in between the n and the theta. Whatever, just do it. Okay, and then we're gonna do the L. 1 times -1 is -1. And it's all underneath that -2. Okay, so we're making it smaller. Now I wanna somehow get this to be smaller into just one thing. Okay, anytime you ever see sine squared, something squared with a 1, like a plus or a -1, it should alert. Anytime you ever see something squared and a 1, alert. And it probably means alert yourself to the Pythagorean identities. Let's look for a Pythagorean identity that says sine squared and a 1. And maybe instead of this sine squared and a 1, I can replace it with one thing. So let's see here. Here's my Pythagorean identities. Here's the sucker that has a sine squared and a 1. It's not quite in the right, whatever. Okay, let me bring that out. It said sine squared theta plus cosine squared theta equals 1. Okay, so I want to make this Pythagorean identity somehow look like sine squared theta minus 1. Yeah, and it's going to be equal to some other junk. So let's try and make this sine squared, oh, that's good, minus 1. So that means I need to subtract this 1 over. Okay, so that means the minus 1 is in a good spot because we have sine squared theta minus 1. But then remember, I told you I want it to be equal to something. Well, let's move this cosine squared, subtract it. Witchcraft. And now it's equal to negative cosine squared theta. I think we've done this a little bit. Okay, so we just made an identity. Look, we just have sine squared theta minus 1, and it's equal to negative cosine squared theta. So this is where we're going to replace. We're going to take this big nasty and replace it with negative cosine squared theta. So this big nasty bottom is negative cosine squared theta. So we get -2 over negative cosine squared theta. Okay, oh my gosh, look, it just keeps getting smaller. What else can we do to make this smaller? The negatives can cancel, sure enough, and you get 2 over cosine squared theta. Okay, now is there anything else we can do to make this smaller? You would say no, but I want to try and take this fraction and turn it into one big whole, like a whole number, like a whole thing. And I'm actually going to use an identity. Let's look for something that has a fraction with cosine on the bottom. Okay, even odd, no fraction with cosine on the bottom. Pythagorean, no fraction with cosine on the bottom. Quotient, there's a cosine on the bottom, but I don't have a sign on top here, so that's useless. Let's look over here at these reciprocals. Cosine on the bottom, look at this baby. Secant theta equals 1 over cosine theta. What? That's something we're going to use. Now we're going to use secant theta equals 1 over cosine theta. Yeah. And that can easily be manipulated, whatever, sound fancy, to the fact that secant squared theta is 1 over cosine squared theta. That's another identity. Or secant to the third theta is 1 over cosine to the third theta. Who the heck cares? Anytime you have cosine on the bottom of a fraction, it turns into a big fat secant whole thing. Cosine squared on the bottom turns into a big fat secant squared whole thing. So cosine squared theta on the bottom, I can bring it up and no longer have it on the bottom. And when I bring it up and no longer have it on the bottom, it becomes secant squared theta, as in 2 secant squared theta. Holy poop, we just simplified it into one thing using algebra, identities, and witchcraft.